Parallels and meridians. Latitudes or parallels. Latitudes are imaginary lines parallel to the equator joining all the places at an equal angular measurement. The North Pole has a latitude of 90° north and the South Pole has a latitude of 90° south. The equator divides the Earth into two equal parts, namely the Northern Hemisphere and the Southern Hemisphere. The most common parallels are 1. The equator, 0°. 2. The Tropic of Cancer, 23.5° north. 3. The Tropic of Capricorn, 23.5° south. 4. The Arctic, 66.5° south. And 5. The Antarctic Circle, 66.5° south. And the Horse Latitudes, 30° north. Longitudes or meridians. Longitudes or meridians are imaginary lines which run from the North Pole to the South Pole east or west of the Greenwich Meridian, 0°. The Greenwich Meridian is the prime meridian which passes through the Greenwich Observatory Station near London where it derives its name. In Africa, it passes through Accra in Ghana. The prime meridian divides the Earth into east and west. Since there are 360° in the sphere, meridians of 0° to 180° lie east of the Greenwich Meridian and the other 0° to 180° west of Greenwich. Determining latitudes. A latitude is the distance measured in angles of any point north or south of the equator at which a perpendicular line is established from the center of the Earth towards the North Pole or the South Pole. 90°. Any angular measurement from the Earth's center to its surface represents a certain latitude. For example, the Tropic of Cancer is drawn on the surface of the Earth with an angular line of 23.5° north measured anticlockwise from the equator. On the Earth's surface, 1 degree of latitude is equal to 111 kilometers. Since the distance from the North Pole to the South Pole is about 20,000 kilometers and there are 180°, half a circle, between them, the distance in kilometers between one latitude and the next must be 20,000 divide 180 equals 111 kilometers. Determining longitudes. A longitude is the distance measured in angles of any point east or west of the prime meridian. The angle of longitude is determined by measuring the angle from the center of the Earth along the equatorial plane, east or west of the prime meridian. Since the world is about 40,000 kilometers round at the equator and there 360° in a circle, the distance between each degree of longitude at the equator must be 40,000 divide 360 equals 111 kilometers. Since longitude lines meet at the poles, the distance between degrees of longitudes becomes progressively less towards the poles. Activity 2.1. Take a ball and mark 2 points on it. These points should be opposite to each other. Draw a line at the center of the 2 points all around the ball. This line can be called the equator. Note that the line divides the ball into two halves. Since the ball is a sphere, each half of the ball can be called a hemisphere. The point marked at the north can be called a north pole and the one at the south, a south pole. Add more circles parallel to the north and south of the equator. These lines are known as latitudes or parallels. Using the same ball that indicates latitudes, the equator and hemispheres, draw lines that join the two poles indicated on the ball, the north and south. Each line can be called a meridian or longitude. This logic applies to meridians on the spherical Earth. Great circles. A great circle is any circle that divides the Earth into two equal spheres. The equator and the Greenwich Meridian together with meridian 180°, are all great circles. Other great circles are the meridian 10° east and 170° west and 20° east and 160° west. In other words, all the meridians are great circles. The equator, on the other hand, is the only latitude that is a great circle. The number of great circles is limitless. Importance of great circles. Great circles are used in water navigation by ships, and aviation by airplanes. They are used to plot routes for ships crossing the oceans to save fuel and time. In aviation, pilots use great circles to mark the shortest path. In general, great circles are the shortest routes between any two places far apart on the Earth's surface. Importance of latitudes and longitudes. The usefulness of latitudes and longitudes are as follows. 1. Latitudes determine climatic variations. For example, the temperature decreases from the equator towards the poles. 2. Longitudes are used to calculate local time of different places on the Earth's surface. 3. Longitudes are used to determine days and dates in the world with reference to the international date line. 4. Both show the location of a place on the Earth's surface. 5. Both help to identify routes for aviation and navigation. 6. Both help to determine distances between places on the Earth's surface. Calculation of local time using longitudes. The Earth rotates on its own axis from west to east once after every 24 hours, 1 day. This means that the Earth turns through 360 degrees in 24 hours or 15 degrees in 1 hour or 1 degree in 4 minutes. All the places along the same longitude experience midday at the same time. For example, if it is 12 o'clock noon in Addis Ababa 39 degrees east, it will also be 12 noon in Dar es Salaam as it is also located at 39 degrees east. On the contrary, places along different longitudes experience different times. For example, when it is 12 noon at places along the Greenwich Meridian, 0 degree, like Accra in Ghana or London in England, it will be 1 p.m. at all places. Along longitude 15 degrees east or 11 a.m. along longitude 15 degrees west. The time recorded along the same longitude is known as local mean time, LMT. How to calculate local time. Example 1. The local time at Tunis 10 degrees east is 3 p.m. What is the local time of Mombasa, Kenya 40 degrees east? Solution. 1. The difference in degrees of longitude between Tunis and Mombasa will be 40 degrees minus 10 degrees equals 30 degrees. 2. The difference in time between Tunis and Mombasa will be calculated as follows. If 15 degrees equals 1 hour, then 30 degrees equals to how many hours? So, 30 degrees times 1 hour then divide 15 degrees equals 2 hours. 3. Since Mombasa is found in the east of Tunis, Mombasa's time will be ahead of that of Tunis by 2 hours. 3 p.m. plus 2 hours equals 5 p.m. Therefore, the time in Mombasa will be 5 p.m. Example 2. The local time at Washington, D.C., 96 degrees west, is 5 p.m. Friday. Find the time and day at Zanzibar, 39 to the power of degrees E. Solution. 1. The difference in degrees between Washington, D.C. and Zanzibar will be 96 degrees add 39 degrees equals 135 degrees. 2. The difference in time between Tunis and Mombasa will be calculated as follows. If 15 degrees equals 1 hour, then 135 degrees equals to how many HRS? 135 degrees times 1 hour then divide 15 degrees equals 9 hours. 3. Since Zanzibar is to the east of Washington, D.C., time will be ahead of that of Washington, D.C. by 9 hours. Thus, 5 p.m. add 9 hours equals 2 a.m. Saturday. Therefore, the time in Zanzibar will be 2 a.m. Saturday. Calculating the longitude of a place using local time. Example 1. Find the longitudinal position of Mogadishu whose local time is 4:40 p.m. when the local time at Tunis 10 degrees east is 2:20 p.m. Solution. 1. The difference in time between Tunis and Mogadishu is given by 4.40 minus 2.20 equals 2.20 hours. 2. Convert the time into minutes. 2 hours 20 minutes equals 140 minutes. 3. Use the minutes to calculate the difference in degrees of longitude between Tunis and Mogadishu. Since the Earth rotates 1 degree in 4 minutes, how many degrees will it take to rotate 140 minutes? Difference in longitude. 140 minutes times 1 degree then divide 4 minutes equals 35 degrees. 4. Since the time of Tunis is behind that of Mogadishu, then Mogadishu must be located east of Tunis. Therefore, the longitudinal position of Mogadishu will be 10 degrees east add 35 degrees equals 45 degrees east. Example 2. What is the longitude of Lindy, whose local time is 8:24 p.m. when the local time in Montevideo, Uruguay 56° west is 2 p.m.? Solution. 1. The difference in time between Lindy and Montevideo will be 8.24 minus 2.00 equals 6.24 hours. 2. Convert the time into minutes. 6 hours and 24 minutes equals 384 minutes. 3. Use the minutes to calculate the difference in degrees of longitude between Lindy and Montevideo. The Earth rotates 1 degree in 4 minutes. How many degree will it take to rotate 384 minutes? Difference in longitude. 384 minutes times 1 degree, then divide 4 minutes equals 96 degree. 4. Since the time of Lindy is ahead of that of Montevideo, Lindy must be located east of Montevideo. Therefore, the longitude position of Lindy will be 96 degree minus 56 degree equals 40 degree east. Time zones. A time zone refers to a stretch of land where the standard time is accepted throughout the longitudinal zone of 15 degrees in width. There would be problems in telling time if every place had its own time set according to the local mean time. Essence of time and time zones. The essence of time and time zones resulted from difficulties in identifying time for a particular area. If each place across a country followed its own time, it would create confusion. For example, Dodoma is about 35 degrees east and Tanga is about 39 degrees east. If each followed its own local time, there would be a difference of 16 minutes between the two towns. There would be confusion in railway and airways timetables or in radio programs if they had to show different times, each referring to its local area. To avoid time confusion, different stretches of land take their time from agreed meridians. The time adopted is known as standard time. In East Africa, standard time is taken from the meridian of 45 degrees east. When the whole stretch of land keeps the same standard time and that stretch forms a time zone. The Greenwich Meridian is the starting point for dividing the globe into 24 time zones. The standard time for Greenwich is known as the Greenwich Mean Time. Greenwich Mean Time. Variation of standard time in a single country. Countries with large stretches of land, for example, Russia, the United States of America, Canada and China have several standard time zones. The International Date Line. The International Date Line, IDL, is an imaginary line following the meridian or longitude 180 degrees west or east, whereby the date changes by 1 day when it is crossed. The line is internationally agreed upon. However, the IDL is not straight for the purpose of avoiding crossing land masses which would cause a country to have 2 different days at the same time.